47 is, again, a lot of just a big box. Just a big box. Sine theta plus cos theta squared minus sine theta minus cosine theta squared. Box and box. That's it. Two boxes. Box over here gives me sine squared theta plus 2 sine cos plus cos squared theta minus, whole thing is minus, you know, I'll put a big bracket here, minus this with the box, sine squared plus cos squared minus 2 sine cos. Again, does anybody need to see the box? If so, don't hesitate to ask. Doing the box on these two. If you're good, you can begin simplifying. I'll go ahead and take care of the box on these. Box on the left side first. There's one piece more here. So let's see what we get here. We get sine squared plus 2 sine cos plus cos squared. Over here, box now on this side. Sine times sine, sine squared. Sine times negative cos is negative sine cos. Sine times negative cos, so negative sine cos. Negative cos times negative cos, cos squared. So what do we have? We've got sine squared minus 2 sine cos plus cos squared. Any questions with regards to the box? Box says. Okay, seeing none, let me continue the problem. So picking up from here, I can now combine. So inside the brackets, let me simplify first. This plus this is just 1. Sine squared plus cosine squared is just 1. Sine squared plus cosine squared is just 1. Go ahead and distribute the negative. The 1's go away. 2 sine cos plus 2 sine cos. I would have loved for the answer to be 4 sine cos. Unfortunately, that's not an answer choice. That's what makes this like a level 5, not level 4. We need to remember that 2 sine cos is another way of saying sine 2x. This is an answer choice. In fact, it's answer A. Let me stop here and take some questions. Okay. Anything else you need to do on this packet? 48, okay. Okay. So on 48. Alright, so on 48, here we are. We got a nice right triangle here. And we know that because of this. And now they're saying which of these 3 options can represent side z. Well, the first one said square root of a squared plus b squared. Well, that's good because we know a squared plus b squared equals c squared. So square root of a squared plus b squared absolutely equals c. So number 1 was true. So answer choices B and C have to be wrong. Then they're saying b, side b, of course over 1, remember any fraction that doesn't have a denominator is over 1, times secant of alpha. They're saying that might equal c. Let's find out. Well, secant of alpha, if you think about it, remember SOHCAHTOA. Secant is 1 over cosine. So here's the key, folks. If cosine is adjacent divided by hypotenuse, secant must be hypotenuse over adjacent, because it is the reciprocal of cosine. Remember, secant equals 1 over cos. So b over 1 times hypotenuse over adjacent, hypotenuse over adjacent. The b's cancel out, and I'm left with c. That's good. Number 2 works. Answer has to be E. But I'll prove number 3 as well, just in case the answer choices were written better. Number 3 says b over 1 times cosecant of beta. So here's beta. How am I going to do this? Well, we know that cosecant is the opposite of sine. Remember, cosecant is 1 over sine. So if sine is opposite over hypotenuse, cosecant must be hypotenuse over opposite. So b over 1 times hypotenuse over the opposite of this is this. And there we go. We're in good shape. All 3 work. Correct answer is E. Questions? All right. Let's go to this packet right here. The last year's exam. Let's read the answers to 1 through 8. One through 8. Number 1 is D. Number 2 is F. Number 3, B. Uh, 4, seen this question before, is J. Number 5 is E. 4J, 5E. Number 6 is F. 7 is D. And 8 is H. We need to repeat. Leslie? Nothing to repeat? Okay, which one should I work? Leslie? 3, anything before 3? Okay, let's do 3. On 3, the most commonly missed answer was E. A lot of people chose E. That was probably the most commonly missed answer, but B is correct, and we will find out why. So they tell me, number 3, that pi is less than theta, which is less than 3 pi over 2, and tan theta is 2 over 9. Now, here's the key, folks. This statement tells us a lot. This is saying theta is bigger than pi, so bigger than 180. Here's 180 degrees. And smaller than 3 pi over 2, smaller than 270. So it must be somewhere in here. So, this is Q3, which means theta must be in Q3. Theta in Q3. So if we know theta is in Q3, that means sine and cosine. Sine is negative in Q3, and cosine is negative in Q3. And now they're telling me that tangent is 2 over 9. Well, unfortunately, 2 over 9 is not on the unit circle, so I should probably draw a triangle. Opposite over adjacent. Remember TOA. Opposite over adjacent. And now I can use Pythagorean theorem to get the left side. Bless you. Bless you. Bless you. Bless you. You're welcome. So we now found our third side, that is to say our hypotenuse. And now we simply want to know sine of theta plus cosine of theta. We want sine of theta plus cos theta. Well, sine of theta, so sine is opposite over hypotenuse. Opposite over hypotenuse. Opposite over hypotenuse. Negative because I'm in Q3. Plus cos, so TOA, adjacent over hypotenuse. Negative because I'm in Q3. Need to add these fractions. Denominators are the same. Negative 11 over root 85. But, unfortunately, that's not any of the answer choices. We need to multiply by fancy 1. So root 85 over root 85. And we get negative 11 root 85 all over 85. So there's number 3, answer B. Questions on that? Okay, what else am I doing? Nothing else? Okay. Here are the free response answers. And free response, I mean referring back to this packet. Referring back to this packet. And I think we did 1 and 2. So here's 3A. Here's 3A. Let's start here, and then we'll project 3B into the 2 proofs. So here's 3A right here. Let me take questions on this, if there are any. Any questions on this? Okay. Here's 3B. Here's 3B. I may have, I don't know. I just want to make sure everybody